drones are having difficulty fulfilling their function. Shahed from Iran. Even during flight, many are shot down and fall to pieces. And it's not just the conventional weapons of the United States that are responsible for this. A technology that, in theory, shouldn't even be active yet, is already destroying these threats almost instantly. This seems like something out of science fiction, but it's already a reality on the battlefield. Laser weapons. And so far, Iran simply doesn't know how to react to it. But before we begin, don't forget to like and subscribe to our channel. According to the New York Post, a U.S. Navy destroyer in the Middle East has been equipped with a system completely different from conventional weaponry. It's not a missile or a cannon. It's the Helios, high-energy laser with integrated optical dazzler and surveillance, a naval system capable of firing laser beams at drones and other aerial targets. These lasers destroy targets almost instantly, burning their structure and disabling their systems. Furthermore, they eliminate the need to use expensive missiles to shoot down cheap drones, completely changing the balance of the conflict. This development further aggravates Iran's situation, whose military capacity has already been severely compromised. Estimates indicate that much of its offensive infrastructure and air defenses have been destroyed, leaving it mainly with the use of drones and missiles. Developed by Lockheed Martin, Helios is installed on warships and fires high-power energy, over 60 kilometers, using fiber laser technology. The system is highly automated, with advanced sensors and algorithms that allow it to identify, track, and hit targets with precision, possibly with minimal human intervention. The concept appears to be to install a Helios module on a ship and have it fire lasers at any threat coming from the sky. The system also presents several advantages, as highlighted by Lockheed Martin in 2021. The company stated that the Helios system, with its virtually unlimited inventory, low cost per kill, light speed delivery, and high precision response, meets the fleet's current needs, while its mature and scalable architecture allows for increased laser power to address additional threats in the future. Translating the marketing pitch, the Helios costs virtually nothing per shot, can fire as long as there is energy available, and will become even more powerful over time. The New York Post adds that there may be some level of human interaction with the Helios, especially in controlling its steerable head. Presumably, this means that operators inside the ship can point the module in the direction of threats before allowing the automated systems to handle the firing. All of this seems too good to be true, or a real nightmare for the Iranian regime. But we know it works, as tests prove that Helios is real, and the United States may even have another futuristic weapon in operation, but we'll get to that in a moment. In the testing field, Naval News reported in early 2025 that the United States Navy conducted a test with Helios at the end of the previous year. In that test, the United States attempted to hit a target simulating a cruise missile from the deck of the USS Prebly. We don't know much more than that, since the 2024 annual report from the Director of Operational Test and Evaluation, which confirmed the laser weapon tests, didn't provide many additional details. At a minimum, the United States collected data on how Helios would perform against a missile-like threat, which may have been used in the ongoing development of the system, which, according to Lockheed Martin, only tends to improve over time. The Navy Times presented a slightly different interpretation of this report. According to the source, the Navy's test was indeed successful, although it was conducted against a drone, not a cruise missile. Furthermore, the New York Post reports that the U.S. Navy announced in early February that it had used the Helios missile in successful tests that resulted in the destruction of 4 drones. Returning to the Navy Times, the newspaper published a photograph, supposedly taken directly from the report, showing a huge beam of white light emanating from the USS Prebly, giving an idea of how powerful this laser is. This is not a thin beam like that of a laser pointer. It is a continuous stream of intense energy being released by the same types of ships that Iran attempts to target with its drones. Shahd. Therefore, everything indicates that Helios works and, according to the New York Post, it has already been used against swarms of Iranian drones. But there are two caveats to this story. The first is that the United States has not officially confirmed that Helios is being used in Iran. What we have so far are images of what appears to be a Helios system installed on a Navy destroyer, in addition to scattered reports about the use of laser weapons. Regarding the second caveat, it's also possible that the system was incorrectly identified or that it's being accompanied by another laser weapon, further reinforcing the futuristic power the United States is bringing to the conflict. What weapon is that? This is the type of analysis and information you want to see more of. As for the other weapon, it's the Odin. On March 13th, the New York Times reported that indications that Helios is aboard a ship near Iran may be mistaken. The publication quotes Jared Keller, author of the Laser Wars newsletter, who states that the system seen in the photo shared by the New York Post is actually Odin, not Helios. If that's the case, we need to look at what the United States is using on its ships from a different perspective. The Odin isn't exactly a direct drone destruction system like the Helios, although it is also a laser weapon. The difference is that the Odin's beam is designed to disorient approaching drones, rather than destroy them directly. The idea seems to be to deflect them from their trajectory, causing them to fall away from their targets. Presumably, a disoriented drone can also be forced to reduce its speed, making it an easier target for other weapons, such as cannons and missiles. According to the Army recognition, images released at the start of Operation Epic, Fury images indicate that the Odin system was already in the field. The photos, published by the U.S. Central Command, show an Arleigh Burke-class destroyer launching Tomahawk missiles. But closer analysis reveals the presence of a laser system on board, possibly operating in conjunction with these attacks. This system would be Odin, identified by characteristics similar to those seen in other images associated with Helios. Unlike destructive lasers, Odin was not designed to directly destroy targets, but rather to interfere with the sensors, cameras, and systems of drones, causing them to lose orientation or crash. Furthermore, it can even affect manned aircraft, generating an intense glare capable of hindering pilots' vision and compromising maneuvers. Most impressive is the speed of its development. In about 2.5 years, it went from concept to real operation, already being used, for example, on the USS Dewey. In practice, this means that the United States combines different technological layers. While systems like Odin disorient the drones, other means, such as missiles or even more powerful lasers, destroy the targets. Given this, Iranian drones end up neutralized before even completing their mission, while Iran's already weakened air force plays practically no relevant role in the conflict. At the same time, evidence is emerging that Israel is also employing laser weapons. Videos show rockets being destroyed almost instantly after launch, something too fast for conventional systems. This raises suspicions about the use of the Iron Beam, an even more powerful system with around 100 kilobars. The Iron Beam uses two high-energy lasers integrated with radar and command systems, forming a highly efficient defense. Its distinguishing feature is precisely the dual system, which improves performance even in adverse conditions such as rain or clouds by reducing beam dispersion. All of this reinforces a clear shift on the battlefield. Lasers are no longer experimental. They are becoming central components of modern air defense. Assuming the system operates as intended, it fires an extremely concentrated beam about the thickness of a coin directly at the target's critical point. If the iron beam is indeed in use in the conflict against Iran, this would represent yet another significant threat to the regime. However, Israel maintains that the system is not being deployed and is not even ready for continuous operational use. This version, however, raises doubts. There are records showing that variants of the iron beam were successfully used against dozens of Hezbollah drones in 2024, indicating that the technology works. It is possible that an update temporarily disabled the system, or, alternatively, that Israel is keeping its use secret to preserve the element of surprise. At the moment, everything remains in the realm of speculation. Meanwhile, the scenario becomes even more unfavorable for Iran. The United States' technological advancement is not limited to laser weapons. It also extends to the space domain. The conflict has already entered a new phase, combining laser warfare with advanced space capabilities, something Iran cannot keep up with. This new type of warfare becomes evident with a recent statement by Donald Trump, who claimed that American and Israeli forces can intercept Iranian missile launchers within 4 minutes of launch. This requires locating these systems almost instantaneously, even though they are mobile and operate stealthily. And this capability exists. According to experts, the United States uses satellites with infrared sensors capable of detecting launches at the exact moment they occur. With this data, it is possible to quickly identify the origin of the launch, coordinate interceptions, often with Patriot missiles, and alert forces on the ground to take cover. In practice, this means that each Iranian launch can reveal its own position, making the launchers immediate targets. It's a radical change on the battlefield, where speed, precision, and integration between space and ground combat define the outcome in a matter of minutes. Hundreds of Iranian missiles have already been neutralized thanks to this technology, which instantly detects the heat generated by the launches and allows for an almost immediate response from defense systems. There is also the possibility that the United States is using sensors to identify infrared signatures directly in Iranian territory, revealing launches in real time and enabling rapid strikes with aircraft or long-range weapons. Although it's unclear which specific space system is being used, technologies like Sky Defender may be part of this process. With the support of satellites equipped with infrared sensors, developed in partnership with companies like Thales Alenia Space, it's possible to identify launches even before ground-based radars detect the missiles. Artificial intelligence then processes this data and precisely locates the points of origin. In practice, operators receive this information, triangulate the launcher's positions, and execute attacks within minutes, rapidly eliminating new threats. This points to a new scenario, not just laser warfare, but also space-based warfare, where Iran is technologically behind. Systems like Odin and Helios are already demonstrating what the future of combating drones will look like. What was once experimental is now becoming operational, preventing drones like the Shahed from completing their missions. Beyond their speed, superior even to missiles, the biggest advantage of lasers is their cost. While a single laser launch might cost around $3.50, a Patriot interceptor missile exceeds $3 million. With this enormous difference, the trend is clear. As they evolve, lasers should gradually replace missiles as the primary defense. Simply put, laser weapons like the Helios can shoot down hundreds of thousands of drones for the same cost as a single Patriot missile. This clearly demonstrates the magnitude of the change. We are entering a new era of drone warfare, with the United States leading this transformation. If more systems like Helios and Odin are deployed, and if Israel puts Iron Beam into full operation, Iran's main strategy could completely lose its effectiveness. the country relies heavily on drones, Shah-D, but this model only works as long as the cost to take them down is high. When cheap lasers start destroying them in seconds, this logic simply ceases to exist. Data indicates that thousands of drones were launched in just a few weeks. However, if these low-cost weapons are being neutralized by systems that are even cheaper to operate, all the economic advantage disappears, along with the drones themselves. In a short time, the United States significantly changed the dynamics of aerial combat. The combination of lasers with satellites equipped with infrared sensors allows for the detection, tracking, and neutralization of threats with unprecedented speed and precision, drastically reducing the effectiveness of Iranian attacks. And this wouldn't be the first revolution of its kind. In the past, other technologies have completely redefined aerial warfare, and one of them, which emerged in the 1950s, remains essential to this day. If you want to find out what this weapon is and why it continues to dominate the skies, stick with us and be sure to subscribe to the channel for more analysis of the most advanced military technologies in operation.